Hey, Mr. Van here. This is lesson 10 from Illustrative Mathematics, Geometry Unit 8, or as we teach at Coastal Academy High School, this is Unit 1 of Math 2. So this lesson was all about dependent or independent events. Dependent or independent. Now, we can mostly logically sort out are two things independent or dependent. However, there's also a formula for it to quantify how dependent or independent things are. And we can use that to come up with some conclusions as well. But let's start off with just sort of thinking this through. So if we're talking about independent or dependent, based on their descriptions alone, what you're going to think is, does one event actually change or affect the probability of the next event? So the example we've talked about in class is flipping a coin and then rolling a number cube. Let's say you flip the coin first and you get heads, and then you roll the die. When you roll the die, the probability of getting a 4 is not determined in any way by how the coin flip worked out. They're completely independent. There's nothing, they don't affect each other in any way. Another situation where the first event does in fact affect the probability of the second event would be that they're dependent, would be something like if you're drawing colored marbles out of a bag. Let's say you got red, blue, and green. You pull one green marble out of the bag and you leave it out of the bag. The next marble that you go pick, the probability that it will be any given color might have changed. It should have changed because the total number of marbles is going to be smaller, but also if that was the only green one and you pulled the green, the probability of getting green the next time you pull a marble is 0. There's no chance of getting a green if there's no greens left in the bag. So that greatly affected the probability. Let's say there were 4 green marbles in the bag. First person grabs the green marble, keeps it out. Well, now instead of having 4 green marbles to choose from, you're down to only 3. And you also have fewer marbles in general. So the mathematical way that we can quantify this is we could say, if I could figure out what the probability of A given B is, and the probability of just A, if those numbers are the same, that means that this B event does not affect A at all. Probability of A given B being the same as probability of A means that B doesn't matter for this probability or this one. So we're going to check and see if those things come out to be the same. Another formula for checking for independence is that this probability of A and B, if it comes out to be just almost the same, it doesn't have to be exactly perfect, by the way. If it comes out to be almost the same as the probability of event A times the probability of event B, then the things are independent. On the cool down, you're going to want to use these probabilities equations here as much as possible. So let's take a look at the activity. So here's a table of values, and here's another table of values. Use this probability of a temperature greater than average, given that the pressure is less than or equal to average, to determine whether the events are in fact independent events. So probability of temp greater than average given pressure less than or equal to average. If we figure out the probability of each of those things individually and multiply them together, it'll show whether or not these are independent. If they come out to be exactly the same number or even relatively close to each other, then we would say that these events are independent. However, if those two numbers, if the probability of A and B is not close to the probability of A times probability of B, then we would say that those are dependent events. All right, I hope that helps. Number 2 is similar to that. If you have any questions, let me know.